All right. Okay. Well, I hope the homework's coming along okay. And this week we are going to cover object-oriented programming. Okay. And we'll cover this today and Wednesday. And then I hope to have everything done by Wednesday for object-oriented programming. And then on Friday, I hope to start ggplot. We'll talk about ggplot. And I know some of you have already exposure to ggplot and others not. But anyway, the midterm exam will be next week. And that will cover up through object-oriented programming. So this lecture and the next lecture. And that will be that, okay? And I'll talk about that later. All right. So let's see, object-oriented programming. Okay. Anybody take other programming classes other than R? Oh, okay, a lot of you. Like Pick 10 or what? Okay, something other than Stats 20 or Pick 10? Okay, what'd you guys take? Okay, 31. Okay, so C++, yeah.
Jog 173.
What's that?
That's Python.
Python. Okay.
Yeah,
All right.
yeah.
Okay. So if you have C++ stuff and Python stuff, you're familiar with object-oriented programming. Okay. And for those of you who haven't, I'm going to introduce some stuff here. And so we've got object-oriented programming in R, and I think it came in a little bit. I don't know the full history, but it feels a little bit like an afterthought. And R's primary system is S3, okay? But there's actually like 4 different object-oriented systems in R. There's S3, there's S4, there's RC for reference class, and then the newest one is R6. But R6 actually isn't officially part of R, but I think it's preferable anyway. Okay. Different opinions about object-oriented systems in R, because there's 4 of them, and so which one are you supposed to use? So, I'm like a big fan of Hadley, and he says S3 and R6 are the most important, and after reading what he had to say about it, I'm in agreement, but, again, I'm like your evangelist for Hadley Wickham and the Tidyverse. So I hope you are okay with that. And so today we're going to cover S3, and then on Wednesday we'll cover R6, okay? And then you're going to get a homework assignment that will require you to use R6, okay? So that's coming up, just to get you guys thinking. All right. Okay, so there's a few different paradigms for object-oriented programming, okay? In R, S3 and S4 use what we call the generic function object-oriented programming system. And that is different from probably any object-oriented systems from other languages. So if you used Python or C++ or Java, those are all going to be encapsulated object-oriented programming, okay? And so that was introduced in R, relatively recently in reference classes, and then R6 is kind of an improvement upon that. And the whole concept is that, you store your information in objects, and then these objects are capable of doing actions or have functions assigned to them or associated with them, I should say. And those functions are called methods. Okay, so if you've learned another language, right, you've probably learned what we call encapsulated object-oriented programming, and basically, your function calls will be object.method or something like that, okay? And the object encapsulates both the data in fields and the behaviors with methods, okay? And so my example of this is you can think of like having an object called camera, and the camera will have fields being like information it stores, such as how many pictures have been taken, how much memory is available, okay? And then as far as the behaviors and the actions that the camera can do, you'll have verbs like shoot a photo, focus, record a video, stuff like that, okay? And so these are actions that this camera object is capable of doing. And so you can imagine some kind of system where you have like multiple cameras set up, and then you say camera 1, shoot video, or shoot a photo. Camera 3, do video, okay? Or something like that, right? And so you can imagine something like that, right? So object-oriented programming is useful because you can create multiple instances of an object that each kind of do a different thing. All right, and so we have encapsulated object-oriented programming in R6 and reference class things, okay? And then on the other hand, we've got generic function object-oriented programming, okay? And this is, I would say, the primary and most important one for R is S3, okay? And so in generic function object-oriented programming, the methods belong to the functions themselves. We call them generic functions. Objects or classes store data in the fields, but the objects don't carry information about the methods. Instead, when you call a function like a generic function, that function looks at the object class and behaves differently based on the object class. So in real life, our brain kind of does this, right? So if I give you the word shoot, okay, and I give you a camera, then you're going to say, okay, this means I'm going to take a picture, right? If I give you a hockey puck and I say the word shoot, that means you know you're supposed to hit this towards the goal or something. Or if I give you a gun, you know that means you're supposed to pull a trigger. So what this word shoot means takes on different behaviors or actions depending on the object that we're talking about. And this is how generic function OOP works, okay? And so we would call these things polymorphic functions because they have, I guess, multiple forms, okay? And S3 and S4 are polymorphic object-oriented systems. And pretty much all of the objects that are created in kind of your base R is done via S3, all right? And so that's what we're going to do, okay? So for example, one of the functions, summary, right? So you call summary on a vector, okay, and it behaves differently, right? Okay, so up here we have a numeric vector. So here's a data frame called diamonds, okay, and it has information about a whole bunch of diamonds, and one of the things that it keeps track of is like the size of the diamond, the carat, okay? And if you call summary on a numeric vector like diamonds $carat, it's going to give you things like the mean and the max and the minimum and stuff like that, okay? Meanwhile, cut is a factor, okay? And if you ask summary on a factor, it's going to basically give you a tally of each of these things, okay? And so the way the summary function behaves differs based on the object you've given it, right? Kind of like that verb shoot, it takes on different meanings or different actions based on the object we give it, okay? And so this is how it works, right? And so so class is the definition of an object, and it's going to contain fields that we use to store information, okay? And then a method is some version of a function, right? So you have a generic function like summary, and you're going to have the version of the summary function for numeric vectors. You're going to have the version of the summary for factors and things like that, okay? And those different versions of that function are called methods. Okay, so a class defines an object, and a method defines what the object can do, okay? And then another important idea is inheritance, okay? And so you have, there's often the classes might be created in some sort of hierarchy, all right? And so you might define a new class, and you're going to say this class inherits from some parent class, okay? And that way, you know, maybe you've got a function, a factor that, so for example, there's what we call the ordered factor, okay? An ordered factor is pretty much a regular factor, except the levels have a specific order, right? So actually, I think this is diamonds cut is an ordered factor, okay? Because fair is the worst. So as far as cut goes, when you buy a diamond, the best is ideal, and then there's premium, very good, good, and fair is the worst, okay? And, you know, it's kind of like t-shirt sizes. there's a natural order, right? Small, medium, large, extra large, double extra large, and things like that. So sometimes you have these categorical variables where a natural order exists, and we'll call those ordinal variables, whereas other categorical variables do not have a natural order. For example, colors, right? So if we talk about, flowers and stuff, should the red flowers come before the blue flowers, come before the yellow flowers? Okay, the order of colors is not. There's not as much of a natural ordering. So there's like rainbow order, but then where do you put colors like magenta and brown and things like that, right? So those would be nominal variables, right? Okay, so anyway, so ordered factor inherits from a regular factor. So you might have methods that apply to a regular factor, and then you'll have methods that apply only to ordinal factors. And basically, if we don't find a method that exists for the ordered factor, we're going to find the method that exists for a regular old factor. Okay, and similarly, tibbles inherit from data frames, so that pretty much everything you can do with a data frame, you can do with a tibble as well. All right, and this is just a bunch of terminology here. When we say which method are we supposed to use, this process is called method dispatch, right? So your brain has some kind of method dispatch, right? So if I give you a hockey puck and I say shoot, your brain says, oh, I need to find a stick so I can hit the hockey puck, type of thing, right? And so similarly, the computer needs to have some kind of system that says, you've given me an object of this particular class, I need to find the correct method or the correct function to do, right? And so that's method dispatch. And so in R, what we have is a generic function, and the generic function will figure out what to do, right? So for example, print, summary, plot, these are all generic functions that when you give plot the output of a numeric vector, it plots kind of these dots and stuff. If you give it the output of a linear model, a matrix with two columns, it's going to create a scatter plot and things like that. So its behavior differs depending on what it gets, right? All right, so once again, base R has three object-oriented systems: S3, S4, and reference class, right? S3 is going to be kind of the simplest, and I would say the most important. It's very flexible. It's kind of ad hoc. Okay. S4 is similar to S3, but it makes everything formal and a little bit more rigid. Okay, because people might say, I can't believe you can do some of this stuff with S3, and it's because S3 is the system without any rules. S4 basically applies rules, so you can't do illegal things. Reference classes is to do the encapsulated or message passing object-oriented programming. And then there's R6, that's not part of base R, okay? But it's arguably a better implementation of reference classes or a better implementation of encapsulated OOP, and so that's what we're going to learn in this class. Okay, so in our class we're going to learn S3, and that's going to be today's focus, and then Wednesday we'll cover R6. All right, and then there's base types, okay? And so base types are not object-oriented programming, but they form kind of your building blocks on which all of the other objects are built, right? So everything that we've covered so far, your atomic vectors and stuff like that, those are going to be base types, okay? You find out the base type using type of. These are things, your common things, kind of like the atomic vectors, your lists, functions, environments. Those are all base types, okay? There's more, exotic base types, such as calls and promises, and sometimes you might get a glimpse of those, but not to worry about those, okay? And pretty much objects, so for example, a data frame is an object built out of what base type? a data frame. Data frame is built out of what base type?
Yes.
A list, right? Yeah, okay. And we said basically a data frame is a list where all the vectors are of the same length, okay? And so, so you already have some exposure to data frames, to the S3 object-oriented system, because data frames are S3 objects. We just haven't really explained all that. And so anyway, base type you use type of, and it will tell you what type it is. A lot of these things have names that make sense, right? You give it an integer vector and you say type of, it'll say integer, and then you can ask is.integer and it says true, okay? But there's some things that are weird, right? So if you give it a function and you say type of, it says closure rather than function, but then the question is dot function, and then and other functions are what we call primitive functions, and their type of is called a built-in, but you don't call them you don't say is.built-in, you say is.primitive. All right, so it's a little confusing there, and it's unfortunate. And again, I think it's because when they were first coming up with the S language, which is the predecessor of R, R is like the open source version of S, I think they thought of these things a little bit later, and so it wasn't consistently designed. You didn't have like Guido van Rossum coming up with, master planning all of the stuff. All right, so we have is object, okay, and is.object, and this will tell you if it's a base type or if it's something other than that, right? So if it's a base type thing, is.object will return false, whereas if it's something else on top of them, like an S3 or an S4 or whatever, is.object will return true, okay? All right, so let's talk about S3, okay? There's not an easy way to check if something is S3. You have to kind of use a combination. You can do is.object, and that needs to return true. And then there is a function called is_s4, and that needs to return false, okay? So if it is an object, but it's not S4, okay, then it will be an S3 object, okay? Unfortunately, there's an is_s4 function, but no is_s3 function. So go figure, right? Okay, so data frame, you ask, is that an object? It says true. Is it S4? It's false, right? If you extract out one of the columns, data frame $x, that is not an object, right? That's just going to be an integer vector, okay? Is.object data frame $y returns true. Why is that? All right, we're just pulling out the column where when we defined the data frame, we said y is equal to letters 1 through 10. A, B, C, D, E, F, G, H, I, J. Yeah.
Because it's single bracket, so then it's returning the list.
It's not returning a list. If I do df $y, I'm not going to get a list. What am I going to get? I'm going to get A, B, C, D, F, G, H, I, J, but it will be a factor, right? So the default behavior of data frames is to make things factors, right? Character strings into factors. And so df $y is a factor. So it's technically an integer vector, okay? And it becomes a factor. And so if you say, is that an object? It's going to say true because it's not just the integer vector, it's a factor. And a factor is an object. So that's what's going on. All right. So we talked about generic functions or generics. S3 methods do not belong to objects or classes, and that's the other stuff, all right? Okay. So if you, so one thing you can do is you can just see the code that R uses to run a function, right? You just type in the name of the function, but you delete off the parentheses. Okay, and if you hit enter, it shows you all the code that R runs when you call that function. So like if you type in lm, and you delete off the parentheses, it'll like show you all the code that linear model runs. Okay, so when you call mean, the code that you see is actually very anticlimactic. It says use method mean, right? It says this is how we calculate the mean, and it's called use method mean, right? And so whenever you see use method, that means it's a generic function, okay? So use method is the way R implements method dispatch, right? It says, okay, you called the function mean. This is a generic function. This behaves differently depending on the class of object you've given me, right? So if you give it a numeric vector, it's going to calculate the mean probably the way we traditionally expect. But if you give it something like a date, and you ask for like the method of the means for some date thing, it's going to do something a little bit different, okay? And so use method will have to look up different versions of the mean function, okay? There's also internal generics, and this is even more, not more confusing, but it's, so some of the functions, like sum, are not executed in R code, but it's written as a C function, okay? And you have these generic functions for kind of the C versions, the C codes, and these are called internal generics, okay? And these include things like the single square bracket for subsetting, sum, and cbind, and they don't use method, they use dispatch group. They're all internal generics, okay? When you look at a function that is a method for an S3 thing, it's going to take the form of the generic name dot the class name, okay? So the name of the generic function dot the name of the class that it applies to, okay? Generic dot class. So the mean function is generic. This is what you type in, right? When you call and you ask R to calculate the mean of something, you just type in mean parentheses, and then you give it the vector, okay? If the vector you have is date information, what R is going to do is it's going to find this function, mean.date, okay? Mean.date is the version of mean that applies for date objects, okay? You have the print function, and you have like the generic print function for most vectors and stuff. But then when you print out a factor, it looks different, right, than an integer vector, right? So if you have an integer vector, it's going to look some kind of way. And we know a factor is built on top of an integer vector, but when you print out a factor, it looks different. And the reason why is because print.factor is the method that is being called when you call print. So you give it a factor, it's not using the generic default print method, it's using print.factor. It looks up this function. Okay, and so because it's generic dot class name, generic function name dot class name, it's generally discouraged to use dots in object names. Okay, there's some exceptions like t.test. So you have t.test, but this is technically a little ambiguous because somebody who's accustomed to this might think this is the T method for class test, okay? Because this is how it's kind of written out. Now we know that t.test is how we conduct t-tests and Welch tests and things like that. And similarly, we all call everything data.frames, okay? And so print.data.frame is the print method for data frame class objects, but someone else could be confused and they could think it's the print.data method for frame class objects, right? Just because it's a little bit ambiguously named. Now we know that this is the print method for data frame objects, but because of the ambiguity of using the dot, we encourage underscores for object names, right? Such as read underscore CSV and as underscore Tibble and things like that, okay? There's a package called prior, written by Hadley Wickham, no surprise here. And basically, it allows you to test if something is an S3 generic function, right? I got it, this printed things out. But so you can say is t-test a generic function? And it actually is, okay? There's different versions of t-test for different classes, okay? We're not quite accustomed to this, but you can see this if you just type in t-test, again, without the parentheses, it shows the code internally that it runs, and it uses use method t-test. And anytime you see use method, that's a clear indicator that it's a generic function, right? So use method is the clear indicator that it's generic. So meanwhile, you have t.dataframe, okay? This is not a generic, it's a method, okay? It is the method of t that applies to data frame objects, right? So t is the transpose function. So if you want to take a matrix and transpose it, you're going to call t on a matrix, okay? But you can also use it on data frames. You can also use it on apparently G-tables, trellis, and other types of objects, which I'm not too familiar with. I'm really only familiar with the data frame and the default versions, okay? Because they basically do the same thing, right? And so, for example, when you create a matrix, the matrix generally fills it by row, right? And then we said 4 rows. So this X is originally a 4x3 matrix, 4 rows, 3 columns, and then you call transpose on it, T on X, and it makes it a 3 rows and 4 columns. All right, it's transpose the matrix. Okay, but again, the generic function for T is that it's going to call t.default, right? Whereas here on the data frame, I've created a data frame, 4 rows, 3 columns, A, B, C are my columns, and then I transpose it, and now I've got 3 rows, row A, row B, row C, and 4 columns. Okay, so you can transpose a data frame as well. And similarly, even we call the same function, the function is just t. I don't have to remember, hey, there's a special version of t. R just knows to call that version of the t function, right? You know, another example, like in real life, if I give you a baseball bat and I say swing it, you know, you're gonna swing it like a baseball bat, right? And if I give you a golf club and I say swing it, your motion is gonna look different, right? You would look silly if you swung a golf club the way you swing a baseball bat. And so similarly, you know, rather than having to specifically say swing it this way or swing it that way, I can just say swing it, and your brain will say this is the appropriate way to swing, right? And similarly with R, you can just say transpose this, and it knows, or well, using method dispatch, it knows this is how I'm supposed to transpose it. Yeah.
Is it a significant time cost at all when you use something like this, where it's like searching for like the specific type?
No, it's quick.
Okay.
Yeah. Right, like how long, like when you type print an object, it's not like you're waiting around for, I mean, I'm trying to think like how many, I think print is probably one of the methods that have like hundreds of methods, or is one of the functions that have hundreds of methods associated with it, but it's not hard to figure out, right? So, or it doesn't take the thing long, right? So when you call mean on a function, there's different versions, right? There's the mean function for date objects, for default, for time difference objects, for, I don't know what these other things are, okay? The t-test behaves differently depending on whether you give it a data frame, like with 2 columns, then it will know to kind of do things, versus when you give it a formula, because you can also conduct a t-test using formula, right? Formula notation, t, y, tilde x, and things like that. Right, and we can see the different methods associated with a generic function using the methods, right? So we say methods, and you give it the name of the generic function, and then it will give you all of the different versions. So it says there's mean.date, mean.default, mean.difftime, okay? You can also look up all of the methods that belong to a particular class. So class TS is time series objects, and there's all sorts of methods that are specific to time series objects, right? So there's a cbind method that's specific to time series objects, and I don't know, all of these other things, show and plot and stuff. All right, so let's get into S3 classes, right? So it's very informal, okay? Basically, you just so you can do it in one step, right? So there's a function called structure. You give it whatever base type you're going to build on top of, and you say class equals my class. All right. So here and now I have defined a new class of objects called my_class. Okay. You don't even have to use the structure function. You could just say, okay, I'm creating a list, and we're going to call this my object. Okay. My object is my list. It's an empty list. And then after the fact, you say, oh, wait, you know what? Let's make this a my class object, my_class. And boom, we have defined a new class, my_class. All you have to say is class of my object, and then you assign it this. Okay. So it's very informal, right? It's kind of like you take a stick and you just say, you know what? This stick is going to be a baseball bat. Okay. And then it's like you've got the low budget prop department in theater class or something, and you just say, all right, here, look at this thing. Pretend it's a baseball bat. And now everybody has to pretend this thing, you know, the pool noodle is now a baseball bat, and we're going to swing it around like it's a baseball bat. Okay. So that's it. You just take whatever object you have, and then you just say, hey, you know what? Treat it this way. Treat it as a my class object. Okay. And then, so once you have that thing, you can check and say, well, what kind of class is it, right? And so you say class, and you give it the name of the object, and R says, oh, it's a my class object, okay? You can check if you want a true-false type of thing, right? So sometimes you need to, like in functions with an if things, you say, is it this particular class? So you can say, does it inherit from my class? And that's going to return true or false, right? And you might just say, well, why don't I just do class my object equals my class, okay? And the reason why is because class can actually be a vector of classes. You can have, so an object can inherit from multiple classes, and so you might get a vector, right? And so if you try to just say, is the vector equal to some particular thing, you're going to get true false values, right? So if you just want to say, well, does this thing inherit from a thing, you have the inherit function. Okay, yeah, so here's the example. The diamond's data frame, or the diamond's data, is actually stored as a tibble, okay? And we can see that tibbles, there's tibble_df, there's tibble itself, and data.frame. So I guess there's different versions of tibbles, and so there's three classes associated with diamonds. If we look at the $cut, okay, the cut column, which is an ordered factor, it says the classes associated with this column is an ordered factor and then just a factor itself. It's an ordered object or a factor, okay? Right, and so and when you have when you get a vector of classes, it's going to go from most specific to least specific objects. Okay, is that all right for multiple classes there? Okay, this is not required. Like when you're working with S3 generics, again, you can just assign factors after the fact. You can or classes after the fact. You just say class of this thing is now this. That's fine. But, in general, if you're thinking of using classes and S3 objects seriously, you generally want to create a constructor function, okay? So a constructor function is going to be a function that creates objects of that particular class, right? And you're going to have one argument for whatever base object that you are building out of, okay? And then, or it should have two principles, have one argument for the base object, okay, and one for the attribute, right? And then and it should check the type of base object and the types of each attribute, right? So, for example, to construct a object of class data frame, you have the data.frame constructor. To create objects of class factor, you have the factor constructor, right? And so it's not a law, right? R will allow you to do this where you create your constructor and it has a different name than the class that you are producing. But I guess that would be considered poor practice, okay? Best practice is the constructor function has the same name as the class that you're creating, right? So here we can create a constructor called myClass, okay? And my_class will create an object of my_class, okay? But there's no law that says that R is not going to produce an error if this function has a different name, something other than my_class, right? It'd just be confusing for the next person who reads your code, which might be you. All right, and then so basically all this is doing is just my class has to be numeric, right? So this is like such a minimal constructor here, but there you go. Okay. Again, S3. So R has no checks for correctness, right? So here I create a linear model. I take data empty cars, and we're going to do predict miles per gallon based on engine displacement, right? And it's a log-log model. So we do this, and it produces an object of class LM, right? And this means that when you print out this linear model on empty cars, or the log model on empty cars, it prints out this way, right? So when you call, like you guys took 101A, or you're taking it 101A right now? Okay, so you produce the linear model, and then when it prints out, when you just print the thing, it just gives you the call and the coefficients, right? Okay, and have you guys ever thought, how is the linear model stored in R? How is it stored? It's stored as a list, okay? It's stored as a list, right? And okay, so this is a bad idea. Don't do it, okay? But R will let you do this. You can just say, hey, this linear model I just created, you know what? Let's treat it like a data frame, right? So it's like, I don't know, you buy a hammer from the hardware store, and you say, you know what? This we're gonna call a baseball bat, right? And you can do it, and now you're gonna try to play baseball with a hammer. You're gonna run into serious problems, but there's no when you say no, that's a baseball bat, you're swinging it wrong. Now you have to take the hammer and you got to swing it like a baseball bat, and R is going to do it, right? You're going to say, okay, well, you called this a data frame, so I'm going to try to print it out like a data frame, and it says, well, I don't know how to do this. I got 0 rows here, right? And you might be scared, like, did I lose my information? No, the information is all there, okay? So you can still do $ coefficients, and that information is still there. But you have told R, I want you to treat this thing like a data frame. Even though it's a linear model, I want you to treat it like a data frame, right? And R says, okay, you got it. You're the boss, okay? So this is S3. There's a lack of built-in validation of classes, okay? And it could be problematic, right? If you intentionally do this stuff, right? But as long as you're not intentionally doing these things, it's rarely a problem in practice, right? Nobody has said R has fallen apart because its linear models objects aren't always required to be linear model objects, okay? So yeah, while you could, right, while scientists were obsessed about thinking what they could do, they never thought about whether they should do it, and that's the same principle applies here, right? R is not going to protect you from yourself, right? That's S3. Now S4, on the other hand, someone said, hey, I don't like this. I don't like that people can do this stuff. S4, you bought a hammer. It has to be a hammer. It's the law that you must treat a hammer the way a hammer is, right? It's like you buy cleaning chemicals from the store, and they come with all of these like federal warnings about like it's against the law to use this improperly, and I don't know who's going to arrest you, but it is, right? I guess you'd be tried in a federal court for using your cleaning chemicals the wrong way. All right, so we have, okay, so that's creating S3 objects. Those are creating the objects, S3, that's how you do it. Man, okay, we got to talk about generic functions. How did I only get through 40 slides here? Okay. Generic functions are created by calling use method, right? So the name of the function is my underscore generic, and you're going to use use method. And again, you're going to call it my underscore generic. Now, again, you don't have to have these two things named the same way. R is not going to force that, but you're just going to end up confusing yourself if you name it some other way, okay? Maybe I should include some examples of bad code. And basically, this is how you implement a method, right? So my underscore generic is the name of the function, dot my class is now the method that applies to objects of my class, right? So here I've created an object. My object is class of my class, and so when I call the generic on this object, it runs the function which just produces this character string that says this is a my class object. Here, this is, you can create, so there's already the mean function, okay? And you can say, you know what, I want a special version of the mean function that applies to my class objects. It's just going to return the number 5, okay? And so you say, what's the mean of my object? And again, the object itself is just an empty list, okay? It's an empty list with class my class, okay? But when you call it, it says the mean of that object is 5, okay? Which is kind of silly, but R is just following exactly what it told it to do. So method dispatch, you're asking, does it take long? Okay, basically what R does is it says, okay, I'm going to just create a whole bunch of names to search, right? Generic dot, and then it gives all of the classes, and it's going to search for all of these things, okay? So, so here's a generic, okay? Here's F. It uses method F. We create f.a and f.default, okay? f.a, if that runs, it returns class A. f.default will return just the string unknown class, okay? So here, I create an empty list with class A, and I run function f on it. And it says, oh, that's class A, it returns class A, okay? Here I create a list, empty list with class B and A, and what this is going to do, when I call f on this, it searches first for f.b, which doesn't exist, so it goes down the list and it goes to f.a, and it says, oh, I found that, and it returns class A, right? Here I create an empty list with class C, and I call f on it, and so it's going to search f.c, and it doesn't find that, okay? And so it goes to the default, and the default will be unknown class. Now, if you ever create a use method, you should always create a default method as well, okay? Because if you don't, so here here I delete the default method, and if I call f on class C, okay, then you get an error here, okay? And I forgot there's one more slide here. And so this is an empty list of class C, and I call f on it, and it searches for f.c, and it couldn't find it, so it uses the default method and returns unknown class. But you can also, again, you can say, I want you to take this hammer and swing it like a baseball bat, and you can force R to call method f.a, because it's just a function, right? It's just a function with the name f.a, and you can call that, and it's going to work that way, all right? Not a great idea, okay. All right, let's see. I'm going to have to figure out what to do here, because we ran out of time, so maybe we'll have to spend some stuff. A lot of this is just some quiz questions here, so we'll end there. All right, we'll see you guys on Wednesday.